Hello, welcome to this sixth video on factoring in a series of videos. If you're here, you should have already watched the overview factoring video, as well as the videos that demonstrate the techniques for factoring problems that involve greatest common factor, differences of two squares, perfect square trinomials, and easy quadratic trinomials. This video is going to focus on how to factor harder quadratic trinomials. So let's move into the concept map and take a look at some overview here. There are some prerequisite skills for factoring harder quadratic trinomials. One is you have to be able to list factor pairs, which is a pretty easy skill, but it's a very important skill. A little bit harder is you have to be able to factor with GCF. Although this is a demonstration on how to factor quadratic trinomials that are a little bit harder, one of the steps in the method I'm going to show you is to use GCF. So you have to have that skill secured. Also, you're going to need to be able to FOIL. It'll help you check your problems because when we factor these types of problems, we create what looks like a FOIL problem. So the skill of FOILing will help you check your work. And as the video develops, we will take a look at a list of steps. They're somewhat extensive because these are problems that are a little bit harder, but they're listed out with pretty solid clarity for you to work with here. Okay, so let's talk about factoring harder quadratic trinomials. Well, if we remember, an easy quadratic trinomial was one that looked like x squared plus bx plus c. And we talked about also is that what made them easy is that the multiplier or coefficient of the x squared term was always 1. Well, you probably guessed then that what's going to make the problems harder is when that the a is not 1. So they're still going to be of the form x squared plus bx plus c, but there's going to be a multiplier or coefficient for the x squared term that's not equal to 1. And this is, in fact, what makes them harder. Okay, let's just jump into some examples here, and I'll review the steps that I've listed out for you. They're listed here. Again, step 0, as is the case in all of our factoring problems, is to factor with GCF if possible. We always want to look to do that first. Then, if you can't do that, the parts of the process here that are distinct to harder quadratic trinomials are listed here as 1 through 5. And the first thing to do is multiply a and c. Just pointing to this first example here a little bit. A here would be 2 and 21 would be c. Again, it's the first term and the last term we look to find a and c. And then we're going to determine the factors that what I'll call them f1 and f2 of AC whose sum is b. Somewhat similar to easier quadratic trinomials where we use the factors of c whose sum was b. Now we're using the factors of AC whose sum is b. Then we're going to set up the box organizer, which is this guy down here. I think I'm going to do that by way of an example. It'll make more sense and have some context that'll help you move through understanding what the box means and how it's used. And then you're going to determine the GCF of each row and column in the box. Again, we talked about GCF being an important skill. You need to have it secured when we go into this process because a step in this process involves GCF. And then you're going to write the answer as a product. That product will probably be something that looks like two quantities, and that can be FOILed back out to see if you in fact get back the original problem. Okay, so let's go right into this example here. We're going to factor with GCF if possible, and these three terms have a GCF of 1, so not much to do there. Then I'm going to multiply A and C, which is 2 and 21, and get 42. And then it says to determine the factors, which I'll call F1 and F2, of AC whose sum is B. So I'm looking to get two factors whose sum is 17. That's the B here. Okay? So listing them out, I get 1 and 42, 2 and 21, 3 and 14, 6 and 7, and that exhausts the list. Now, we should see here that this 3 and 14 is where I'm getting a sum of 17, so I'm going to want those factors. Now it says set up the box organizer. Okay, well, let's look at the box organizer. If we see here, ax squared, which is just the first term of the problem, goes in the top left part of the box. So I will write 2x squared here. And then we should see pretty quickly that c, which is the last term in the expression, goes in the bottom right corner of the box. So I can put that in pretty quickly too. It's just 21. Now this part here might be a little more confusing where it says f1x and f2x. Well, when I found f1 and f2, those were the factors whose sum was b. So I'm going to call 3f1 and 14f2, which means that I'm just going to put 3x in the top left corner of the box and 14x in the bottom left corner of the box. Now the order does not matter. I could have in fact put 14x here and 3x here. Okay, so don't get hung up going which one goes where. It really doesn't matter. Now I'm going to determine the GCF of each row and column in the box. Okay, I have to have my GCF skills readily in place. So what's the GCF of 2x squared and 3x? That is going to be x. And what's the GCF of 14x and 21? That is going to be 7. Now, going up the columns, what's the GCF of 2x squared and 14x? That will be 2x. And what is the GCF of 3x and 21? That will be 3. Now it says write the answer as a product. That product is going to be of this quantity and this quantity. Okay? So I just write in any order, it really doesn't matter. I'm going to write x plus 7, the quantity thereof, times the quantity of 2x plus 3. And if in fact I FOILed that all back out, you would see that I would get the original expression. Okay, I'll just do another example for you here. It's a little bit of a long process, so multiple examples will probably be a help to you. So factor with GCF if possible in this expression, 6x squared minus 7x minus 5. Well, the GCF is 1 of all 3 of these terms, so I don't really need to factor out a GCF. Then it says multiply a and c. Well, in this case, it's 6 and negative 5. Be very careful making sure you get the sign. So it's going to give me negative 30. So now I need to find the factors of a, c, that I'll call f1 and f2, whose sum is b. Now b here, you notice, is negative 7. Okay? Well, I'm factoring a negative, which means I'm going to get 1 positive and 1 negative. For their sum to be negative, the larger number has to have the negative sign. So that's my right column. Again, if you remember from easy quadratic trinomials, when the last sign is negative, you're going to get 1 plus and 1 minus. And then you realize that the sign of the middle term is the sign of the bigger number, so you'll see it appear in the right column when you factor. Okay, so I'm just looking for a sum of negative 7. So it's not 1 and negative 30. It's not 2 and negative 15. It is, however, 3 and negative 10. I can stop there just for clarity of the list. I'll show you that 5 and negative 6 don't have a sum of negative 7. But again, 3 and negative 10 do. So setting up my box, ax squared, which is the first term, goes in the top left. So I'll put 6x squared there. C, which is the last term, negative 5, goes in the bottom right. And then my factors that I needed to make the middle, they go in the top right and top and bottom left, excuse me. So I will say that I will use the 3 with 3x and the negative 10 with negative 10x. Okay? So, moving on from there, I now will determine the GCF of each row and column in the box. So what's the GCF of 6x squared and 3x? That's going to be 3x. And then what is the GCF of negative 10 and negative 5? Well, because negative 10 is considered my first term and it's got a lead negative, I need to pull out that negative and say it's going to be negative 5. Just a general rule when you use the box organizer. If where you're writing is touching a negative, you will write a negative. Okay? Similarly here, when I go to factor up, you notice that the 6x squared is not negative, it's positive. So the box that I'm touching against here where I'm writing will be positive. So what is the GCF of 6x squared and negative 10x? We should be able to see that that is 2x. And what is the GCF of 3x and negative 5? That is just 1. So writing my product here using these terms and these terms, I will in fact get 3x minus 5. That quantity times the quantity of 2x plus 1. And as always, you could take your factored answer, FOIL it out, and you would see that you would get the original problem. Okay, moving on to some other examples here, where I have 15a squared minus 16a plus 4. You won't always see x's in a problem. The variable here is a, and that's fine, as long as we still have a quadratic where there's an exponent of 2, an exponent of 1, and then a constant term. Okay, so what is the GCF of 15a squared, negative 16a, and 4? Well, again, it's 1, so factor with GCF if possible. It's not. So multiply a and c. So here I'm going to get 15 times 4 is 60. And now I'm going to determine the factors that I'll call f1 and f2 of AC whose sum is b. Okay, well, I see that I'm factoring a positive, but I'm getting a sum that's negative. Well, that means that the factors will both be negative to make a positive, but when I add them, I'll get the negative. So I need negative 1 and negative 10, but that's not negative 16, excuse me, negative 1 and negative 60, but their sum's not negative 16. Negative 2 and negative 30 doesn't work. Negative 3 and negative 20 doesn't work. Negative 4 and negative 15 doesn't work. Negative 5 and negative 12 doesn't work. But negative 6 and negative 10 does. Now, this part of the process here could bog you down. Okay? If you see the factors immediately, go for it and forgo the list. But if you're not sure what they are, you need to make the list. So if they jump out at you, great, save a little time. If they don't jump out at you, take some time and list out your factors. Okay? So we see here that my factors of negative 6 and negative 10 are what make negative 16, which again is the b term. Excuse me, the coefficient of b in the middle term. So now I just need to set up my box. Ax squared is the first term, so that is going to be 15a squared in the top left. C is the last term, which is going to be 4 in the bottom right. And then I put in my factors into the box here where I say I'm going to use negative 6a and negative 10a. Again, the order does not matter here. I could have reversed that order, and that's fine. Okay, now that I've set up the box organizer, I'm going to determine the GCF of each row and column in the box. Okay, so the GCF of 15a squared and negative 6a is 3a. The GCF of negative 10a and negative 4, and 4 is going to be a negative because the wall of the box where I'm writing is negative, so I need a negative GCF. And that is going to give me negative 2. And then when I go up the columns, the GCF of 15a squared and negative 10a is 5a. And the GCF of negative 6a and 4 is, in fact, negative 2. Now, I'm going to write that answer as a product. So I will need these two terms and these two terms and just turn them into quantities. And make a product of those quantities. So I'm going to get 3a minus 2 as a quantity times a quantity, 5a minus 2. And as always, you could take this expression, FOIL it out, and you would get the original expression. Okay, we're going to move on to this final example here. 30b squared plus 57b plus 18. And this example is a little different than the first three, because as I go to factor with GCF, if possible, I see that I can here. I see that 30b squared, 57b, and 18 have a GCF of 3. So I'm going to start this problem by doing 3 times the quantity. And then if you can't mentally divide by 3, you can write the division by 3 of each term. And then get 10b squared plus 19b plus 6. Now, you need to realize that the harder quadratic trinomial is still here. It's the quantity here whose lead term has a coefficient of 10. So now I've got to focus just on the inner quantity here, not 3 on the outside. Okay? So I'm going to multiply 10 times 6 and get 60. And then I'm going to look for the factors of 60 whose sum is 19. All the signs are positive, making it a little easier. 1 and 60 doesn't work, 2 and 30 doesn't work, 3 and 20 doesn't work, 4 and 15 does work. I'm going to stop there to save a little time. Now, I'm going to set up the box organizer. Again, ax squared, which in this case is my 10b squared, is the first term. That's going to go in the top left. And then I'm going to see that my c, which is my last term, again it's the 6, not the 18, it's the 6, is going to go in the bottom right box. And then we're going to use my magic factor pairs here, which were 4 and 15, whose sum was 19. And then I'm going to make 4b and 15b in my remaining boxes. Again, that order does not matter. So from there, I'm going to determine the GCF of each row and column in the box. So what's the GCF of 10b squared and 4b? It's going to be 2b. And what's the GCF of 15b and 6? That's going to be 3. And then what's the GCF of 10b squared and 15b? Will be 5b. And the GCF of 4b and 6 is going to be 2. I then need to take these terms and create a product, but I have to remember that I started with factored out term of 3 here. So I'm going to say it's 3, then times the quantity, 2b plus 3, times the quantity, 5b plus 2. And as always, foiling that out with distribution of the 3 in the appropriate manner will give us an expression that's equivalent to the original. So, that's the examples in a nutshell. I'll take these steps and just take a quick screenshot. I'll include the box organizer here. And then I will put them back in our flowchart to shrink it down. It is a sizable algorithm. So from there, we'll just pretty much finish up this sub-flow chart. Again, the steps are a little bit long. I think they were well reviewed in the examples. If you're going to practice some problems, I would be looking at these steps. So maybe having this part of the video on pause so you can look at the steps, or if you wrote them down, that's fabulous. But this is a beefy algorithm. You'll have to refer to the steps until you get them committed to memory. So that's a good study skill, just to use your resource until you don't need the resource anymore. So I hope you've enjoyed the video. Tend to some practice problems, and when you're ready, it'll be an appropriate time for you to move to the next method of factoring.